Okay, thank you, Roger and Thomas, for inviting me to this fascinating conference. So we've heard a lot today about optimal policies and how to get towards the social optimum. I'm not going to be ambitious in that direction. All I'm going to do is talk about something much more short-term in some sense, which is given that we are not making much progress in terms of solving the climate problem, and given that we have a particular structure in place that has evolved so far, what can we do given this structure to make it maybe a little bit better and somewhat more effective? And that is with reference, of course, to developing countries. So the big picture here is, as you can see, that we have in this graph population in billions on this axis, and we have greenhouse gas emissions in tons of carbon dioxide equivalent per year on this axis. This data is a few years out of date. And the color coding is basically, this is North America, these colors, this is Europe, this is Asia, this is Africa, okay? Now, what jumps out at you from this graph, by the way, this is an area measure, that's 5 gigatons of CO2 equivalent per year aggregate, because we have per capita on this axis and we have population on this axis, okay, per capita emissions on this axis. And of course, the obvious pattern is that the richer countries, North America and Europe, have higher per capita emissions because they have higher energy consumption because they're richer. And the poorer countries out here have lower per capita emissions because they have lower energy consumption and production because their incomes are lower. And the crux of the problem is that with regard to development is that, as you can see, these countries, Asia and Africa, have a lot of the world's population, right? And China in particular, already this picture is within a few years quite out of date for China, and so you would actually have Chinese, the box actually being maybe twice that size today. And that same phenomenon is happening and might happen to a considerable degree with these other countries. So India has already been growing faster. This is India here. And the African countries, not only might they start growing much faster than they have done, in fact, African growth rates have picked up in the last decade or two, compared to previously. And they are now, some of the African countries are now among the fastest growing in the world. But African populations are also expanding. So what you're going to see is that the emissions coming out of Africa are going to go up, both because they're going to expand in population this way and per capita incomes are going to rise. So we're going to see, if you looked at this graph a few years from now, then you'll see a lot more color up here, basically, because there's going to be a lot more emitted, right? And of course, these are poor countries, right? So it's difficult for them to pay extra costs for more expensive green energy. That's the crux of the problem, right? Here, the problem is somewhat different because you have slow income growth and you have basically no population growth to worry about, right? So it's less of a problem. Okay. So that's pretty much summarizing what I just said. So emissions are going to basically increase in the poor countries a lot because populations and income are going to grow. And these countries don't have the money to pay to slow emissions. And it's ethically highly questionable to ask people who have very little to restrict their consumption in order to, for the greater good. Also, it's not politically feasible to do so either, right? Because these are sovereign countries. Which leaves us with basically, three possibilities. We do have to prevent developing world emissions from growing, right? And that's the only way to reduce world emissions, because it looks like developed country emissions, at least there's some possibility of reducing them. but that shouldn't be overwhelmed by developing country emission growth. And so what are the possibilities, right? This doesn't leave very much. So one possibility is that emission reduction is done in the developing world as a byproduct of domestic development policy. Right? A second possibility is that it becomes free to not emit. That would happen if the costs of technologies that, like solar, wind, and others that don't emit, become substantially cheaper than the existing system, right? Or that there are transfers, right, to enable these countries to pay for somewhat more expensive energy access than they would have got if they just used off-the-shelf fossil fuel technologies. So let's look at the first of these possibilities, which is mitigation as a byproduct or co-benefit of domestic development policy. This has been talked about a little bit already. And there are some possibilities here, clearly. There are subsidies to fossil fuel industries in many countries in the developing world, and there are local pollution externalities from fossil fuel consumption that haven't been internalized. And some of these might be quite large. So there's this paper out of the IMF last year that suggests an implied carbon price of $30 per ton of CO2 in India and $60 per ton of CO2 in China, which is a lot compared to nothing, right? So, but this analysis ignores the fact that there are cheaper ways to deal with some of these externalities than to tax fuels. For example, if you think about particle emissions from diesel in India, so this is a big air pollution problem in India, right? One of the most polluted countries in the world in terms of air pollution, particle emissions. It is a problem, and people are becoming increasingly aware of it. But, for example, the cheapest way of doing this is simply to do what the developed world has done, which is to have fuel quality standards and some tailpipe, some stuff you stick on the tailpipe to make sure that whatever's left doesn't come out. And it's extremely cheap to do this, actually. It would raise the cost of diesel by less than 1%. That's the calculation that's been made by some studies that have analyzed it. By the way, it's not being done, right? Which brings me to my next point. Environmental concerns are simply not high on the list of priorities of countries where there is a very large number of extremely poor people, because the politics is all about other things that have to be delivered first, right? So even though there's increasing environmental consciousness, even though we have a massive pollution problem, which is very cheap to solve, so far anyway, there's no sign of any action on this front. China is richer. It's more than twice as rich, maybe about 3 times as rich as India, depending on how you believe, what sort of PPP indices you believe in. So it's about 2 or 3 times as rich as India. And in China, you can see more action happening on the pollution front because, again, there's an income effect. And so people are worrying about the environment as well as about getting richer. So think about this. If India were to reach China's emission level when these concerns got to the point of action being taken, by the way, action is only starting to be taken in China, emissions would already have increased by a factor of 3 or more, right? And if you think back to that picture, you can imagine that you can see that the impact on world emissions is not going to be negligible. It's going to be substantial. So while we can hope that this mechanism will become important, that is, that the mitigation of local pollution externalities and the removal of various distortionary policies can help to solve the problem, I think I, anyway, am not terribly hopeful that this will happen very quickly. I hope it will, but I don't believe it. Okay, so the second possibility is that these green technologies become cheaper than the conventional alternatives, right? And this could happen. It's happening. There's a lot of progress. Support for solar PV in Germany, for example, has contributed to large cost reductions market creation via stronger carbon pricing and other policies would accelerate this process. We all know that. What about innovation? Philippe Aguillon talked about that this morning. That's very important. It's also the case that very little is being done. Actually, this is a little bit like the diesel pollution problem in India. It seems that the amount of money that's being spent by governments on promoting R&D in these green technologies seems to be really small. So if you look at the example of the United States, federal government spends about $2 billion a year on civilian renewable R&D, about $5 billion a year on other energy R&D, out of a total federal R&D budget of $140 billion, right? If the climate problem really were high on the list of priorities, in the same way that if the air pollution problem really were high on the list of priorities of the Indian government, then the numbers would be different, right? But, well, let's hope that they do, the numbers get bigger and action happens. But let's turn to, that is happening, but it's perhaps happening more slowly than we would like. Let's look at the third possibility, which is what I want to spend a little more time on today. Transfers from developed to developing countries to pay for these emissions to pay for these emissions to be avoided. And so there are possible ways of making transfers broadly. There's intergovernmental transfers, that is government-to-government transfers. That's what the developing country governments want. That's what they go to the negotiating table about mostly. And this is, of course, from the developed country perspective, politically difficult. In fact, probably it's just a non-starter. Okay. All right. So a second possibility is linking carbon markets. So you can have carbon markets in the developed countries, and you can have carbon markets in the developing countries, and as long as the developed country caps are more strict than the developing country caps, then the transfers would go in the right direction. And that's extremely attractive because then you can hide these transfers, right? And that makes it politically easier. But you have to have the carbon markets in the developing countries. And in the low-income countries, I think that's difficult. It's a non-starter. You need an institutional infrastructure. You need some credibility. All that becomes very difficult. So I don't think that's going anywhere anytime soon. And as I said, I'm focusing on soon in the next few years. Right now, what can be done? All right, and so I want to talk about, I think, what is somewhat more realistic, which is offsets from developed country carbon markets, from carbon markets that have been created in developed countries, and that continue to be created to some degree, for better or for worse, even though it seems that the tone of the majority of the talks today seem to suggest that rather than tradable permits, taxes might be a better idea, but the world has gone more in this direction so far. Okay, so given that that's the case, we could look at these offsets. Now, offsets have well-known problems, right? And additionality is an issue. That's the basic problem, and we have had offset programs. There are these voluntary carbon markets. I think those are small scale, so there's no point worrying about them. And then there was the clean development mechanism under the Kyoto Protocol. That was somewhat bigger, and that didn't have a good reputation, I think. It has a deservedly bad reputation. But gaming can be a problem, basically. But I think that doesn't mean that I don't think that we should give up on this possibility, given that we are not in a first or second or third best world. We better do whatever, we better explore whatever is possible. And I think there are some possibilities, and I think that we should think about them. Okay, so here's one example. This is biogas for reducing black carbon and deforestation. So this is a radiative forcer that rarely gets talked about, but it's actually, in recent years, scientists the natural scientists have come around to the view that this is a very important radiative force. It's in fact bigger than methane. There's still a lot of uncertainty about this estimate here, 1.5 watts per square meter, which is, that's CO2, 1.1 watts per square meter, which is ahead of methane, right? So it's a big deal. Okay, so an important source of black carbon, in fact, probably the major source of black carbon worldwide, is the burning of wood and other solid fuels for cooking by the poor in low and low middle income countries who can't afford modern fuels like gas and electricity. And since the science on black carbon is relatively recent, it hasn't been paid much attention to in official communications, and in fact, it's not in the Kyoto Protocol, which was written long enough ago that it wasn't considered very important. And reducing these emissions is difficult because the problem is essentially one of affordability of modern fuels, right? So you have hundreds of millions of people in South Asia, for example, who are still cooking with very polluting solid fuels like wood and crop residues. Okay, so there have been attempts, of course, to reduce emissions from these cooking fires in the past, and these have been motivated by efforts to prevent, first in the 70s and 80s, efforts to prevent forest degradation and deforestation primarily, and more recently to prevent household air pollution. And this is really a huge health problem in the developing world. Household air pollution is estimated to have killed 3.5 million people since 2010. It's the fourth largest risk factor in the global burden of disease in a report that came out a couple of years ago. It's the largest risk factor in South Asia, according to this report, so it's a big deal. And the main efforts to reduce this have been in terms of improving the stoves because the modern fuels have just simply been too expensive. But the problem is that they really don't work very well. They don't reduce emissions by much, and they are just an incremental improvement, and so they don't satisfy people's needs and wants. Now, biogas eliminates nearly all particulate emissions if it replaces solid fuels. It's just like any other, it burns cleanly like any other gas, and because it's a biological origin, it's not a fossil fuel. And there's a paper that we have that looks at the potential for using offsets to finance biogas, for example, and this study has been done in Nepal. So the existing situation is that there is a biogas program run by the government of Nepal. A lot of the finance for this program comes from abroad, not all of it. And the limited appetite for such transfers has meant that there's not all that much money in this program, and so biogas is used by just 3% of households in Nepal, even though the potential reach is much larger. There are lots of people who own cattle, and cattle produce the dung that basically feed the plants. And so the potential reach of this program is very much larger than its existing scope. So if you look at here, you see that up a few years ago, a lot of households in Nepal were still cooking with firewood and other solid fuels, and biogas was just 3%. Okay, this is all households, urban and rural. Okay, so to examine the potential of offsets, we need to find CO2 equivalent emissions reduced per biogas plant. First, we need to estimate the reduction in firewood use per biogas plant. And second, calculate the resulting CO2 equivalent reduction. So if we use these data, and if you look at, I'll just give you this basic result. So you reduce, for every biogas plant, you basically reduce firewood consumption by about 1,000 kilos per year. Okay, that's the estimate. I don't want to go into the identification and all that stuff here. We'll look at various sources of bias and so on. Okay, so let me skip over all that. I'll just say that this estimate is actually quite robust, using different data sets, subsamples, this, that, and so on. Okay, and it's probably a bit conservative because there have been some other studies which have found larger effects, but based on smaller samples. So I don't want to put too much emphasis on that. And so here you get to a calculation of, basically the way you do this is that these are pollutants, carbon dioxide, black carbon, organic carbon, sulfur dioxide, and so on. And these are emission factors. These are global warming potentials. So here the reason that CO2 has a 0.5 is because we're assuming that maybe about 50% of the wood is sustainably harvested given conditions in Nepal, okay? And there's a lot of uncertainty in that number. Notice that black carbon has a very high global warming potential. That's the recent scientific literature. And so you can get tons of CO2 saved per biogas plant. You see the big effects are coming from the black carbon and from the avoided deforestation. If you assume that the price of carbon in some market in the West is $10 a ton, then you multiply this by $10. You use some standard discount rate, and you would get $200. You could spend $200 out of an offset for a biogas plant, okay? And that's about half the cost at the moment. So you could actually subsidize a substantial fraction, and so you would get a substantial expansion, and therefore you could get a substantial impact on emissions. That's the point. And additionality is not much of a concern here because very little is happening without a big financial push. Okay. So you really don't have to worry about how much would have happened if you didn't intervene. Well, not much is happening. So second example here. We have very large increases in coal-fired generating capacity expected. There is a government program, as in Nepal. This is to buy solar PV at utility scale. They're reverse auctions, so prices are revealed in these auctions. And if you look at the latest bids, what we find is that solar is on average more expensive than coal. Okay? And there's separate auctions for solar and coal, but the solar auctions are limited in scale because the government has to pay for them. Right? And it's not willing to lay out more than a certain amount of money. If you do the calculation, you could basically get about 1 cent per kilowatt hour when you value the carbon savings given the average generation mix in India. And so that's about 65, and you can see that that would make a substantial difference in making solar more cost competitive. Right? So it's another possibility that could be explored. The other thing that's interesting here is that the integration of solar electricity into the Indian grid is not going to cause a problem, at least until there are 1 or 2 orders of magnitude, 2 orders of magnitude expansion in the scale. Right? And the reason is because a lot of Indian electricity demand is shiftable around day to night. Or night to day, rather. And also you could have monitoring because you can keep on checking whether whether there actually is additionality in the sense of looking at whether it would happen anyway because the prices are being revealed. So one could work out an intergovernmental agreement in which would facilitate these transfers without the governments being directly involved. Okay, and of course, we know that, well, what's the value of this? The value of this is that basically it would make, for the value of this from the global perspective, is that it makes mitigation cheaper because you can get cheap mitigation in the developing world where this infrastructure is going to be built, right? And you could, which may not be so easy to achieve in the developed world. And if you can do the mitigation cheaply, then assuming that the caps that are set in the developed world are endogenous, depending on what regulators expect the price to be, then you could set tighter caps. So the level of ambition could go up if you think that cap setting is endogenous in terms of the expectations about the price, which I think is plausible. And so to conclude, I think that offset programs can be significant. I don't mean that they're a magic wand, but I think we shouldn't forget about them. And transaction costs can be limited, and well-chosen programs can be monitored in order to avoid the problems with the kinds of programs that we have seen in the past.